Any questions on the homework assignments? All right. So we've talked about this a little bit already yesterday. Find a number that when multiplied by itself, you get a negative number. Well, I'm just going to pick 2. Well, 2 times 2 is? Well, that's not a negative number. And if we take negative 2 times negative 2, we get. So there's no real way to multiply a number by itself and get a negative number. So what we're going to do is we're going to imagine a number, I, as negative 1. And really, I is the square root of negative 1. I is our imaginary number. When multiplied by itself, I squared is negative 1. Because if I is the square root of negative 1, well, the square root of negative 1 squared would be negative 1. So this is our I, our imaginary number. And this here is what helps us get the square root of a negative number. We have I. I is the way that we can do this. So, next page. So if we look at the square root of negative 25, well, when we write this out, well, we can't just take the square root of negative 25 because, as we just said, well, you can't have the number times itself and be negative. So there's no real square root of negative 25. But what we can do is we can break it up as negative 1 times 25. And according to our properties of radicals, we can break this up into the square root of negative 1 times the square root of 5. Now, we can take the square root of 25. And what is the square root of 25? 5. Now, what did we just say the square root of negative 1 was? I. So the square root of negative 25 is 5i. And that's it. Any questions on this here so far? Let's look at the next one. Now, the square root of negative 72. The graphing calculator won't give us it in simplest radical form because it doesn't simplify radicals that way. And the yellow calculator won't do it because negative 72 is not a real number. It won't work. But what do we know that the negative inside the radical is going to come out as? It's going to turn into what? I. Because the negative is going to become I. It is I. And what does that leave us with? Well, the square root of 72. Plug that into the yellow calculator and see what it says. Six squared of 2. Because the yellow calculators will simplify radicals all the way down into their simplest radical form. But what else do we have? It'd be 6 what? 6i. Because by removing the negative and turning it into I, which it will become anyways, it leaves us with the square root of 72, which the yellow calculator will simplify and do for us. So we just need to resolve the I, the imaginary part of it. And we get our answer, 6i square root of 2. Let's look at the next one here, C. Negative 5 times the square root of negative 9. Well, what do we know about the negative and for the negative 9? what's going to happen to it? It's going to become I, which just leaves us with the square root of 9. Well, what is the square root of 9? 3. So we have negative 5 times I times 3, because the square root of 9 is 3. What is negative 5 times 3? And we have our I. So negative 5 times the square root of negative 9 is negative 15i. Yes? So the yellow calculators won't do I. They won't do imaginary terms. Now, if it is a perfect square, so 4 or 9 are perfect squares, the graphing calculator can do those. So we can do, I'm going to do this here. Memory 7, 1, 2, okay. Second square root negative 4. And we did this yesterday, or not specifically this, but did one like it, where it was a fractional, and the graphing calculator gave us an error, yes? I think some of y'all typed it in. Quit. What we can do is we can go into mode, into the mode of the calculator. If we go mode, now, because of last hour, some of these are already switched, but down here it says real. Yours may or may not be highlighted. But if you notice, the next one over from it is a plus bi. This is complex form. This is dealing with our imaginary numbers. So if I go down and select that, it will turn a plus bi on. So if we hit enter and have it selected, we can go second quit. And I'm going to try this again. Second square root negative 4. And hit enter. Now it doesn't give me an error this time. It tells me that it is 2i. So the square root of negative 4 is 2i. Now, if we did it the other way, well, I know the negative is going to come out as I, which leaves me with what? Square root of 4, which is 2. So the square root of negative 4i is 2i. So that means that this is 12 is not a perfect square. So I do know the negative comes out as I. Yes? Well, the square root of 12 is not a perfect square. It won't come out evenly. We could do it by hand and find the perfect squares and reduce that way. Do we have a calculator that will reduce radicals? The yellow calculator, the TI-30XS. What we can do is we can plug in the square root of 12 into it. And it comes out as 2 square root of 3. So it would be 2i square root of 3. So if it's not a perfect square, the yellow calculators will reduce radicals for us. We don't have to do those. We don't have to say that, well, 4 or 12 is the same as 4 times 3. The square root of 4 is, we can't take the square root of 3, so we reduce it down to this here. And that's it. We can look at number 3. Negative square root of negative 36. Is 36 a perfect square? Well, yeah, we could plug it into the graphing calculator. Or if we did it by hand, the negative out front would stay. But the negative inside the radical is going to turn into what? So that leaves us with the square root of 36, which is So the answer is 6i. Any questions on this here?
Is it negative?
Mm-hmm. Yes. Are you ready for the next part? Powers of I. Now, since I is the square root of -1, we cannot leave it with any power. So we're going to start out by saying that, well, I is, by definition, the square root of -1. Well, I squared would be the square root of -1 squared, which is just -1. The square root and square cancel out. I cubed. Because we're just going to keep going with these powers and see something. Well, I cubed is the same as I squared times I. I'm using I squared because we already found out what I squared is, yes? I squared is -1. So we're really saying that I have -1 times I, which is just negative I. Well, I to the fourth. Well, we can say this is I to the third times I. Well, what is I? Excuse me. What is I to the third? So we have negative I times I. Well, that's negative I squared. What did we say I squared is? -1. So we have negative 1, which is just +1, yes? Okay. I to the fifth. Well, that's I to the fourth times I. Well, what did we say I to the fourth was? Just 1, yes? So it's really 1 times I, which is just I, yes? Okay. That might be kind of interesting. Let's look at I to the sixth. Now, I could say I to the fifth times I, but what do we know about I to the fourth? I to the fourth is just 1, so we can say I to the fourth times I squared because we have it multiplied together 6 times. Well, I to the fourth is just 1. What's I squared? So 1 times -1 is? What do we think the next one's going to be for I to the seventh? Well, we can say that's I to the fourth times I to the third, yes? Well, I to the fourth is 1. What was I to the third? So this here is, what do we think I to the eighth is going to be? 1. Because we could say it's I to the fourth times I to the fourth, which is 1 times 1, which is just 1. What do we think I to the ninth would be? I. Because what did we start out with? We had I, then it went to -1, negative I, 1, followed by I, -1, negative I, 1. So the next one would be I, would follow -1, then negative I, then 1. And it repeats in this cycle so that really, for I to any power of n, we're either going to have I, -1, -I, or 1. For any power of I, it's going to simplify down to one of these four. Now what's interesting is if we take that power, whatever the power is, and divide it by 4, we'll get a number. Well, obviously, when we divide two numbers, we'll get a number. But it's going to give us a number point a decimal. We're not really focused on the whole number. We're focused on what the decimal is, because it'll tell us what the power of I will be. Because if it works out that that decimal is 0.25, then the power of I to whatever power is, will simplify to I. If the decimal works out to be 0.50, it'll turn into -1. If it's 0.75, it'll turn into -I. And what would be the decimal for the last one? 1, and its decimal is? So if we get 0.00, we don't have a decimal number, it means it's going to be 1. And we'll always reduce down to one of these four. So if the decimal is 0.25, it would be I. If it's 0.50, be -1. If it's 0.75, be -I. And if it's 0.00 or we don't have one, a decimal place, it will be 1. And try that again. This here is just another way to look at it. When the remainder is 0, 1, 2, or 3, we will get these here. So if I want to evaluate I to the 27th, we can do what? We can take 27 and divide it by 4. Because again, for any I, we cannot have the power greater than 1. So we need to figure out how this simplifies. 27 divided by 4 is going to be 6.75. Now we really don't care about the 6. The main thing we're looking at is the 0.75. 0.75 would be, so I to the 27th reduces to -I. That's it. Questions on this here? We can look at I to the 34th. Here we would take 34 and divide it by 4. $7.5, $8.5, well, it really doesn't matter. It's the 0.5 that we want, and 0.5 corresponds to -1. So I to the 34th is -1. Let's look at I to the 65th. Now the graphing calculator does deal with I. What we can do is say second decimal point, all the way at the bottom, will give you I. And what are we putting it to? Did I say 65th? I to the 65th. We can hit enter. And it tells me that it's I. You might have a little bit funkier number. Yes? Or, I know how to get it. Second I to the 1040, the last one. You got something that looks like this in one of the two ways, either in the front or in the back. Most likely the front number was 3e to the -12 in one of those two. Now, really what this is saying is that I have 1 plus 0.1, 2, 3, 4, 5, 6, 7, 8, 10, 11 for I. What is that number really close to? Yeah, it's really close to what? 0, isn't it? So really, what is this value? 0, so we're left with 1. Okay. Let's do this by our division method, because we can take 10, 40, and divide it by 4, which is 260. The decimal would be 0.00. Since it's 0.00, this reduces to 1. Yes? It's telling us the same thing. It's just approximating, like we saw on graphing, where when we found the intersection, sometimes it would give us 1.45 or 999 repeated, which really is just saying 1.5. It's doing the same thing. It has a pixel error that it's taking into account. So it is really 1. So this does work, but on some of them, we have to interpret what it means, that 0 on one or the other. But doing the division of 4 will work out every single time. Any questions on any of this here? We're ready for what's next. Sum and difference of complex numbers. To add or subtract two complex numbers, add or subtract their real parts and their imaginary parts. Add the parts with I together, add the parts that don't have I together. Or subtract the parts with I together, or subtract the parts that don't have I together. And that's it. So if we look at this here, 8 minus I plus 5 plus 4I. Now we can resolve the parentheses, but because everything's positive, we're adding. It's not really changing anything. We just have 8 minus I plus 5 plus 4I. 8 and 5 are like terms, yes? They don't have I. So what is 8 plus 5? Negative I and 4I are like terms because they both have I, yes? What's negative I plus 4I? And it would be positive. And always we want to write this in the form of A plus BI. That is standard form. Since I is imaginary, our imaginary term will always go second. The real number would go first. And what we call this here, do you have an idea? What are we going over today? It is a complex number. But that's it. Questions on this here? I mean, for this here, realistically, we're just kind of treating I like we would a variable, yes? Because if it was x, terms with x go together, terms without x go together, and subtract. That's a good idea. Why don't we try it in that? Why don't we try it here? Grab a note sheet so I can look at it. Parentheses, 7 minus 6, second, I, close. Minus, open, 3, minus 6, second, I. Did it do it for us? I mean, for some reason, I mean, just took away all the I's, but looks like it gave us the right answer, yes? Well, let's look back at the problem. Well, 7 minus 6i wouldn't change, but I do need to distribute that negative through. So it would be a negative 3. The negative and negative would give us plus 6i. 7 minus 3 is? What is negative 6i plus 6i? Okay, well, it just worked out that these i's canceled out completely. And that's it. So wait a minute. Will the graphing calculators do these for us with addition and subtraction? Oh, yeah. So even if we look at the next one, we can pull the calculator up and say 13 minus parentheses 2 plus 7 second I, close parentheses, plus 5 second I, enter. So the answer for this problem is 11 minus 2i. Because 13 minus 2 is 11. 5i minus 7i would be negative 2i. Any questions on this here? We ready for what's next? Do we need to see another example of addition or subtraction? Okay. Multiplication with complex numbers. Or with multiplication, here we just need to use the distributive property. Well, 4i times negative 6. 4 times negative 6 would be negative, and then we would have our I. Negative 4i times I. Well, 4 times I would be plus, would just be the plus 4. I times I is I squared. Well, what is I squared? It would be negative 1. Now, out of all of the powers of I, that's the one that's really handy to know off the top of your head, because I squared is always going to be negative 1. Because whenever we do multiplication or doing distributive property, this one's the one that's most likely going to come up. And whenever we get it, it's just going to simplify to negative 1. Might as well do that whenever we see it. Because what do we have? 4 times negative 1, which is 4 minus 24i. Because we always want to keep the real number in front. Since negative 4 doesn't have I anymore, it will go in front. And the 24i will go behind it. Questions on this here? So Brian wants to try this in the calculator. Let's do the next one in the calculator and see what we get. 15 second I, open parenthesis, negative 1 plus 2 second I, close parentheses, enter. It'll do it, and that is the correct answer, negative 30 minus 15i. Bless you. Questions on this here? Now we could do this by hand, and we would distribute the 9 and distribute the 2i like we've done with our binomials, multiplying two binomials together. 9 times negative 4 would be negative 36. 9 times 7i would be plus 63i. Negative 2i times negative 4 would be plus 8i. And lastly, negative 2i times 7i. Negative 2 times 7 would be negative 14. I times I is I squared. Now, what did we say I squared was? -1, yes? Well, -1 times the number, well, 1 times 14 would just be what? 14, right? 1 times any number is not going to change it. The negative is doing what? Just changing the sign. So what I do, instead of rewriting it, is I will cross the negative or the I squared out and change the sign. Since it was negative, it's now going to become positive. If it was positive, it's going to become negative. And if it's positive, I will just cross out the positive sign and write a negative above it, just so I know that it changed. Because we could have rewritten it out and had 14 times -1 and got the same thing. Or -14 times -1. Combine like terms, -36 plus 14 is -22. 36i plus 8i is plus 71i. And I have a feeling if you type that in the calculator, you got the exact same thing, yes? We get the same thing for that? Yeah. So the calculators will still do this here, yes? What is the main difference from a variable x and I? Because what is I? The square root of -1, yes? Does x have a definite value? Well, no, x is whatever we plug it in or set it to be, or we are trying to solve for the equation. X, the value of x changes. Will the value of I change? What is I? I is the square root of -1, yes? So does the value of I change? No. Because again, for these calculators, if we plug in a variable, it has to have a value defined for it, yes? Does I have a defined value every time? Yeah, so these calculators, the graphing calculators, will work with I. That's why they won't work with X. Any other questions with multiplication? So we're good with that there. Well, that's addition. Addition and multiplication, addition and multiplication. And that is it. So your homework is on page 131, 6 through 12, 19 through 23, 32 through 38, even, and 44 through 50, even. Now we do have one more part with 3.4, because we are covering 3.4 tomorrow. Because what we've done today is we've dealt with powers of I. We're defining what I is, dealing with powers of I. We've also dealt with addition, subtraction, and multiplication. What have we not done with I? Division. And that's the main thing we're going to be dealing with tomorrow, is dividing. And there's a main trick to it. So most likely it will not take the entire day, so you will still have time to work on the assignment. But that's all we're doing.